All right, here we go. So today we're going to talk about the determinant. So this is Precalc section 8.4. Mostly we're going to be talking about determinants for 2x2 matrices. So the determinant for a 2x2 matrix where it's A, B, C, D. So if this is matrix A equals A, B, C, D, then the determinant, which we denote with the absolute value bars around the A, that equals AD minus BC. So the product of these two entries minus the product of those two entries. So that should look familiar from when we talked about finding the inverse of a square matrix, right? This was in the denominators. So the inverse, right? The inverse, A inverse equals 1 over the determinant of A, and then times, we switch D and A, and then we take the negative of B and C, or the opposite sign of B and C. If B and C are already negative, then we just make them positive. All right. So, why? Why is this, and what does the determinant tell us? So basically, the determinant tells us whether or not the square matrix is invertible. And remember, we've been talking about matrices with respect to systems of equations. So if I have a system of equations and this is the coefficient matrix, so for example, if I have ax plus by equals, let's say something like v, and cx plus dy equals w, you can find the solution to this, right? What we would do is we would just put it in A, B, V, C, D, W. We'd do a bunch of row operations, put it in reduced row echelon form. We'd get this 1, 0, 0, 1, and then we'd have dv minus bw over ad minus bc, and then we would get aw minus cv over AD minus BC. In other words, the solution to this system of equations for any 2x2 system is going to be x equals dv minus bw over AD minus BC, and y equals AW minus CV over AD minus BC. So you'll notice, if you look at this, in order for there to be a solution, the denominator, right, because each of these is a fraction, right? In order for this to have a solution, the denominator cannot be 0. So, for this to have a one solution, AD minus BC cannot equal 0. In other words, the determinant can't be 0. If the determinant is 0, no solution to the system of equations. Or I mean, it could be it could be infinitely many solutions, but there's not one single solution. If it equals something other than 0, you will find a solution to that system of equations. So what this is telling you is basically the determinant determines whether or not that system of equations has a solution. And if you notice the AD minus BC, there's no V and W here. It only relies on the coefficients for the X and the Y. So with our determinants, we're going to be looking at square matrices and basically seeing if it's 0 or not, right, what the value is, a little bit of practice with that, and then we're going to throw some X's in there and just have a little bit of fun with just regular algebra stuff. Yeah, we can talk more during my office hours about how this is used in linear algebra with, like, if you look at a 3x3 matrix, right? A, B, C, D, E, F, G, H, I. Let's say you have that, right? You can think of each one as a vector in 3 space. We can talk about that later if you want to go deeper into it. Just pre-calc though, so we're just going to stick with 2x2s for the most part. All right. So, excuse me while I erase this. That's just kind of like what a determinant is. Now we're going to find the determinants in the inverse for some matrices, and that'll set you up for the first assignment for learning target 1. So let me erase this. Wow, this is so much nicer if I have a little bit of water on it. And then dry it off. Yeah, let's hope it writes after this. There we go. If it doesn't write, it'll left. Whoop, 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 whoop. Okay. So we're going to find the determinant, which we can just say DET for determinant. So find the determinant and the inverse for each of these matrices. And then here we have matrix A. And this is right off of the lesson that I posted for you. So I'm just working through those problems I got on my computer behind me, which is why I keep looking down like that, so I'm looking at what the problems are. So 1, 5, 3, 7. Matrix B. Is negative 4, 1. Negative 2, 1/2. And then matrix C is 2x, 4, 1, and x. 2x, 4, 1, and x. Okay, so let's go ahead and find the, whoop, there goes my pen. Got it. There it is. Let's find the determinant for matrix A. And remember, I don't know if I said this yet or not, but the determinant, we write these absolute value bars around the matrix A. It is not the absolute value of the matrix, but that's just what we use to denote the determinant. So straight bars around the capital letter that denotes that matrix, those straight bars mean we're finding the determinant. So here, remember the determinant is AD minus BC, and this is just for a 2x2, for 3x3, 4x4, larger. There, I dropped my pen again. These are slippery little guys. For 3x3, 4x4, or larger, you can use a graphing calculator for that. You can basically finding the determinants for those is you find a bunch of 2x2 determinants and then multiply them by some numbers and do a combination plus minus plus minus plus minus. It's a big task and it's just not worth the effort, in my opinion. So the determinant here, we're going to go 1 times 7, which is 7. So we're doing A times D minus B times C. So 3 times 5 is 15. 7 minus 15 is negative 8. So the determinant here is negative 8. So now we need to find the inverse. A inverse is 1 over the determinant times, and then we switch A and D. Remember, this is from before our break. So 7 and 1 switch spots, and then we take the opposite sign of B and C. Now for a final answer, we want to distribute that 1 over determinant in. So we can say A inverse equals negative 7 over 8, positive 5 over 8, because that negative becomes a positive. We get a positive 3 over 8, and then a negative 1 over 8. Boom, that's it. That's it. We found the determinant, it's negative 8. We found the inverse of the matrix. All right, now yellow. Yellow. Hi. So we're going to find the determinant for matrix B. So once again, with those straight absolute value type bars around it, we're going to take A times D, so negative 4 times 1/2 is going to give us negative 2, minus negative 2 times 1, the B times C or C times B, negative 2. So here it's negative 2 plus 2, which is just 0. Whoop. So the determinant here is 0. Now, if we were going to find the inverse, we'd go 1 over the determinant. So, right, B inverse equals 1 over the determinant of B, and then dA negative B negative C. But here, the determinant is 0. So here we say that the inverse of B does not exist, and that B is not invertible. We cannot take the inverse of B. And if you look at it, it's like saying negative 4. Actually, if I take 2 of these and add it to that, so 2 times negative 2 is negative 4. 2 times 1/2 is 1. Or let's say negative 2. Right, and then I add it, I would just get zeros in a row. So I'd get zeros, and whatever I had over here for like, if it was a system of equations, I would get 0, 0 number, either no solution or infinitely many solutions, right? So that holds true with if this determinant is 0, there's not one solution to that system of equation that is defined by these coefficients, right? Like if we had negative 4x plus y equals what? And then negative 2x plus 1/2 y equals what? Whatever, doesn't matter what those numbers are, right? If I go negative 2 times this plus that, I would get 0x plus 0y equals something. And there would either be, if it's 0 there, then it would be infinitely many solutions, right? We'd use parameter a, all that. If there's no solution, or sorry, if it's a number that's not 0, no solutions. Right, okay, moving on. Orange. Orange, you're glad I didn't say banana. All right. So here we've got x's in there. So it's a little bit different, but not really. So I'm going to find the determinant. Once again, those straight lines being determinant. A times d, so that's 2x times x, and then minus 4 times 1, so this is 2x squared minus 4. C inverse will have x's in it. Right, basically it's going to be 1 over 2x squared minus 4, and then 2x, 4, 1, and x. Don't worry too much about this with the inverse. Mostly with this, with the x's in there, we're going to be working with these where I'll put an x in there and I'll tell you what the determinant is equal to and you'll have to solve for x. And that's actually what we're going to do next. So with this sets you up for the learning that you're going to use for the first 8 problems of the assignment. So if you're doing the assignment, first 8 problems are based on this, basically. All right. Cool, so I'm going to erase this, and then we're going to go on to problems like that, where we're saying, hey, like, what could x be so that this does not have an inverse, right? In other words, if this is 0, C does not have an inverse. If this is non-zero, matrix C will be invertible. Okay, erasing. So with these next problems, they're a little bit different because we're given a matrix that has x's in them. You'll see the 2 examples for determinant equations. Follow along with Mr. Race's YouTube video that you're doing right now because you're watching it. So here, both of these examples have x's in them. And then the last 5 problems on your assignment are similar to these. Right? There's also the enrichment activity. That is for you to figure out and actually spend some time like thinking about it. So basically on the first problem, we have matrix A, which is x, 3, 3x, and the determinant of A equals 0. And then problem 2, we have matrix B is equal to x plus 2, 9, x plus 2, 9, 4, and x, and then the determinant of B is equal to 12. So we're going to use this information to solve for x. You can probably hear my dog up there. She's excited about matrices. She goes, ref, R-R-E-F, ref, ref. Boom, there we go. There's a little math humor for you. So what I want to do is I'm going to use this knowing that the determinant is 0. So the determinant of A, oh, it's my dog. Come here, Emma, get on that video. Hello, hello, ref, ref. Okay, there you go. Hey, Emma. So the determinant is x times x, or sorry, A times D, right? It's x times x, which is x squared minus C times, or B times C, minus 9. So x squared minus 9 is our determinant. Now we're going to find out what x is, knowing that the determinant equals 0 here. So we've got x squared minus 9 equals 0. We're going to solve that. You could factor, use quadratic formula. Here, we've got an x squared, 0, regular x terms, and then a minus 9 equals 0. So what we can do is we can just solve by working backwards. So I can go plus 9, because it's just an x squared. We can do this, right? X squared equals 9. Square root both sides. Ooh, square root. When we square root during an equation, what do we need to remember to do? You should have just said, don't forget the plus or minus, right? Plus or minus. So plus or minus square root of 9. So here we get x equals plus or minus 3, but we don't like our answers like that because plus or minus 3 is not a number. So we say x equals 3 or x equals negative 3. Those are our two solutions for what x could be. All right. And that's it. So moving on to B. Here we've got this matrix and the determinant is equal to 12. I'm using it. Using my phone right now to make this video. Sorry. My wife trying to take my phone away. You need it. So, matrix B. This is working from home, folks. Sorry. What am I writing here? Yikes, I'm all thrown off. There's no editing either. This is, let me tell you. Sorry, we'll get to this in a moment. I already made this video, but my phone was upside down. I couldn't figure out how to upload it onto my computer and flip it. I could flip it on my phone, but I couldn't flip it on the computer. So this is take 2 with an interruption and a dog. All right, so determinant, a times d. So x plus 2 times x minus 4 times 9, which is 36. Now the determinant, that, which is x squared plus 2x minus 36, is equal to 12. We're going to use that information to write an equation. So now that we have this equation, we can use this to solve for x. So solving for x, let's get this blue one out again. It's quadratic, it's equal to 12. Quadratics are much more simple to solve when they're equal to 0, so we're going to make it equal 0. Minus 12 minus 12. Here we get x squared plus 2x minus 48 equals 0. We got some options now. We cannot solve by working backwards. I mean, if you want to complete the square and then solve by working backwards, go for it. But we can't just go like add the 48 and then square root, because we have that linear term in there. So our options are factoring, completing the square and working backwards, you can do that, or quadratic formula. I mean, or guess and check or graphing, whatever. But I'm just going to use factoring. You could do quadratic formula. That's totally fine. If you don't know it, Google it. You're on your computer already. So here I need two things. Whoop, 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 that multiply, give me this. So these two, I'm going to have an x and an x, because x times x is x squared. And two numbers that multiply to give me negative 48 for the x squared. Whoop. And then they need to add, these two terms are going to add to the 2x. So blank plus blank equals 2. So multiplies a negative 48, adds a 2. What multiplies a 48? Well, 6 and 8 do. And if one of them's negative, like let's say negative 6 and positive 8, those add to 2. So that's what I'm going to use. X minus 6, x plus 8 equals 0. Not our answer yet. Right, we got to solve this. X minus 6 equals 0 and x equals 6. Or x plus 8 equals 0 when x equals negative 8. So here, once again, we get two answers, two possibilities for what x could be to give a determinant of 12. So, kind of setting, hopefully setting you up with kind of an easier first week coming into this online learning thing. If you have questions, please send me an email. Hit me up on Remind. Since I sent out that Remind code, it's on the Google Classroom. You can comment on Google Classroom, and I will post my office hours for when I'm going to be doing a Google Meets video that you can then talk to me and interact with me on that. Now, if this is way too boring for you, I have the enrichment activity. Oh, let's see. Yep, there it is. So the enrichment activity, you're going to use either a graphing calculator if you have one, or you can use an online calculator. And you're going to be looking at the determinant for some 3x3 matrices. And what happens if you multiply those matrices? What's the determinant of that product? How does it relate to the determinants of the original 3x3 matrices? And then how does the determinant change if you take a matrix and multiply it by a scalar? In other words, like if it's 2a, you multiply every entry by 2, how does that change the determinant? So that's for you to figure out. Look at the numbers, try to do it without Googling it. Because you could just find the answer if you Google it, but that's no fun, right? It's learning that you want to do. Once again, let me know if you have any questions. I'm just at home making videos. So, yeah, let me know. Have an awesome day. Stay awesome.